Hey guys, good morning all of you. Can you see that now? Yes. Fine, perfect. So yesterday we went through some IPsec header, right? So let me show you the pre-configuration of the router one right now. So I think so crypto is enabled by default, not by default. I have saved that configuration, right? Show IP interface brief, all good. Show IP protocol summary, perfect. Show run section crypto, right? Everything is good. Okay, I need to give the recording, right? Oh. And okay. All perfect, right? Now all done. And if you come back to the router number 2 and yep, yeah. A set peer means what? I'm going to form the neighborship with this person, right? The crypto peer. I need to tell this person, right? Hey, you are forming a neighborship with this person. I'm making a VPN connection from here to here, right? I need to tell this person. Sanket, get. So this is the phase 1. This is the phase 1 and this is the phase 2. I need to define the key. See, this is the password that I've defined for this person, right? So whenever this person is going to make a connection with me, I need to ask, this guy is going to ask the password and the IP addressing. That's the password is Cisco123 and the IP address is 23.3, right? Then after that I say the set peer means what? I'm going to make a connection with this person. Second, have you watched the first video? तब पता नहीं तो क्यों आ रही है डॉट पूछ ले, समझ में आया नहीं आया? ओके ओके, एक मिनट, इंटरनेट कौन सा चल रहा है? Perfect, all good. So if you go back to the router number 2 is ISP, so IP interface brief, so IP ESGRP enable, all good. Router number 3, so IP interface brief, show IP protocol summary, and so run section ESGRP. If you see ESGRP configuration we have, and all good. And as it is so run section crypto, can you see? All I have a crypto. Everything is good, right? Now if I'm going to ping from here to here, what happened? Try to understand this thing. Ping. Three dot 3.3.3.3.3. Source what? I'm going to put the 1.1.1, right? This is the actual packet that is generated by the user. So we have a source IP address will be 1.1. Destination IP address 3.3.3.3.3, right? And then after that we have a ICMP, right? When this packet is coming to this interface, right, this outgoing interface 0/0, on this 0/0 interface, what we have configured over there? Crypto, right? Is coming with the 101 to the 3.3.3 according to the match address 100. So access list. What I have to do over there? I need to make a VPN connection, right? And I need to encapsulate this packet. Which packet? I need to encapsulate this packet with another header that is known as a ESP. ESP works on the IP protocol. The protocol number ESP stand for Encapsulation Security Payload. So what this guy is going to do, it's something like the header will be something like this. So this is the normal IPv4 header. So you have a IPv4, then you have a whatever the packets you are sending, either you are sending the ICMP, TCP, whatever you want, right? So taking this my IP header, right? Then we have a TCP information, what are the protocol you are going to use, and then after that we have a data, right? The payload, right? This is the normal IPv4 packet, normal packet that user generated. After that, what happened? I'm going to apply the ESP over there. After applying the ESP, how the things will be changed? ESP, IPv4 header, TCP, payload, ESP trailer, and ESP authentication. If you're going to use the authentication, you can use the authentication. Otherwise, this part is optional. And then after that, I'm going to add the original header. Not original, the new header. This is how the packet look like this. ESP, IP header, TCP, payload, ESP trailer, and authentication. What part you are seeing actually? What part? On the, if you capture this link, right? If you capture this link, what part you are able to see? You are able to see this information and this information. Batman. Everything is encrypted except this one is the encrypted part. Except the authentication, right? So now after that, what happened? This ESP is going to further categorize with the two fields. One, we have a SPI, security parameter index, and second field we have a sequence number. Right? Is this something like this? Let me check it. Encapsulation security payload image. Yep. IP header, TCP header, payload. The same thing will happen. IP header, TCP payload, ESP authentication, right? And ESP original IP header. Perfect. Outer IP header. This header, right? This one is a routable. This should be routable. This header should be routable. And this IP is a what IP? This IP is a peer IP. Peer IP in the sense of what? This IP is related to this person that you make a connection to a lot one. So normally I'm sending the packet. If you see this one, if I'm talking about the IP header of this person, source IP is what? For example, I'm sending the packet from the 101. Destination is what? 3.3.3.3.3, right? The same information will be over there. Same information, nothing is different. Same information, nothing is different. Because this is the part is encrypted, right? Once this person is going to match with the ACL, this person is matching with the ACL, right? What I have to do? I need to encapsulate. And what we have to do, I need to make a VPN with this person. So in that case, what happened? I'm just going to add this new header over there. So in that case, what happened? The source IP will be 12.1 if R1 is generating the packet, and destination will be done. This is how the things will happen. So if you see right now, just have a look. R1. I said that capture this link. See, I'm generating the packet from 3.3 to the 3.3.3. Source is what? 1.1.1. Crypto will be negotiate, and once the crypto will be negotiated, what happened after that? You can see the packet. Stop this guy. See, I'm generating the packet from whom? Source 101 3.3.3. How the packet is converted? Same thing is happening, right? If you just have a look over there. 1 minute, I'll do one thing. I put it over there. And how this thing will be converted into this one. Just because of the encapsulation security payload, this guy is going to encapsulate with this person, right? Because I'm making a VPN between this guy to this guy, right? 12.1 to the 23.3. And after that, you will see, is there any information I can see that? No, nothing else. I just have a SPI information security parameter index, right? And then after that, we have a sequence number. This sequence number and this SPI is both are a 32-bit number. 32-bit and 32-bit. This sequence number is just going to prevent the replay attack. It's just going to keep that packet tracking over there. And SPI is just going to make a uniqueness of the packet. If you see right now, if you just go open this packet now, second one. Sequence number 1 is just going to tell you that this is the first packet. If I'm sending the first packet to you, you need to give the reply packet with the same sequence number. Source 12.1 is sending the packet with the sequence number 1. I'm sending this sequence number packet. It's like a TCP three-way handshake acknowledge number. Same thing is happening. I'm sending the packet, right? I'm sending the ICMP request packet with sequence number 1. So you need sequence number 1. So you need to give the reply with the same person, right? Right? Same. If you go for the next packet, take example. Next to one, so this two we have seen. Now next one, sequence number 2. So R1 is sending this packet, right, to the 23.3. This is the source destination, right? Sequence number 2. This is the ICMP request. Now the reply also will be 2. Done. 23.3 and 12. Is there any information can I see over? Nothing. Every single thing is encrypted. I'm just going to add a new IP header. Extra header I'm just going to add out. And this is the comes in the ESP, works on the IP protocol 50 over there. But now, if you just have a try to understand these two things, I'll make a difference between these two guys. Why I'm not going to use the age. So I'll do one thing. Let me capture this guy, and let's capture this thing, and I'll paste it over there. Paint. Done. No, not done. Not properly. 1 minute. Let me capture again. Okay. Now all done. Wait a minute. I'll show you the differences. What are the differences that are there? Then you will understand this thing. Done. All done. Source. So this is my. Come on. Right. So this is my actual topology. I'll take a screenshot of this person as well as. Give me 1 minute. Let me organize myself. Then I'll show you each and everything. Done. So site 1. So I'm generating the packet from whom? I'm generating the packet from this guy to this guy. Right. So here we have a ping. I say that ping 3.3.3.3. Source will be 1.1. This is the actual packet. 1.1. This is the actual packet. And how this packet will convert? Like this one. Right. Coming reply packet is ICMP request and ICMP. Same sequence number. I am sending the packet with the sequence number 2. You need to give a reply with the 2 over there. And this is my actual packet that I am creating. So when this packet is reaching to this interface, what they will do? They will look up for the crypto map. And based on the crypto map, whatever the configurations are there, based on the protocol, they will change the behavior of the packet. This is the ESP of the packet, look like this. But if you come back to this person, let me do one thing. I'm just going to remove the ESP now. How do I remove? So run section crypto. Oh, come on. All done. So what we have to do first, I need to go in the interface 0/0. I first need to remove this person, interface 0/0, no crypto map. Done. And then what we have to do, so IPsec is disabled now. Okay, all perfect. And do so run section crypto now. So I just need to remove this person. First of all, I need to go in the IPsec. I need to remove the T set, and then I need to say that no crypto IPsec transform set. Done. Done. And now I say the do show history. Same thing I need to do on this guy. On a R3 as well as. IPsec off. All done. Okay, what happened? So I remove right crypto map is not relevant. Okay, no issue. And this guy incomplete. Oh, yeah, I get it. I have a different crypto map name is configured over there. That's why. Okay. That's a different crypto map is there. Over there. That's why. Okay. That's a different crypto map is there. No issue. And I need to remove this person now. Now let's apply this thing. Crypto IPsec transform set, same name T set. What I'm going to do, ESP, not ESP I'm going to use. Now I'm going to use the authentication header, AH. Now which algorithm you are going to use? MD5 HMAC. Yep. Done. Exit. Copy the same person on this guy because algorithm has to be same. Done. Exit. Come back to the R3. Do show run section crypto. What I'm going to do, I just need to copy this guy, crypto map IBC, IPsec IPsec, and this guy I need to set transform set T set. I need to call this person interface 0/0 crypto map and ABC. Done. Crypto map IPsec will be on a R1 as well as crypto map C map set transform set T set, right? And I need to apply this guy into interface 0/0 crypto map and C map. Done. All good. Crypto map IPsec will be on. So crypto IPsec SE. 1 minute. Clip. 1 minute. Clip. Clear crypto session. It will delete it now. Just wait for some. It takes, I think so, 30 seconds near around. Near around it will take the 30 seconds. Right. 1 minute. All good. So just wait for some time. Come on. Almost ready, right? Okay, now I'll be generate the new one. Now you see ping. All good. So all the negotiation has happened. Now the difference is that very simple difference. Echo request and echo reply. Come on. See, negotiation has complete, right? You see that? And we, if you see the session, we have a session over there. Reply the cam. SA. See. This is the previous one, so I'm going to delete this one. Don't worry, we'll go through this one as well as what are the states are there. Don't worry. All good. And if you see the show crypto, IPsec SA. I have said the 4 packet, right? So the difference is happen over there. If you just have a look, the difference. What is the actual packet was there? This one. Right? Now try to understand this part. Yep. It's so everything. Can you see? The differences happen. If I'm going to put the ESPs, this is the ESP, right? In ESP, what happened? This is the actual packet, but this actual packet is complete encrypted, right? This actual packet is complete encrypted. Whereas in H, what happened? Nothing is encrypted. This guy is only going to provide the, if you see the difference, I'll do one thing. Take a capture, a screenshot, and take a screenshot of this person. This difference. What AH is doing over there? This guy. Authentication header works on IP protocol 51, whereas ESP 50. Another thing, internet is slow. Done. Whereas what ESP allow you? ESP allow you should be encapsulate, or we can say that completely encrypted. Whereas AH only provide data integrity. That's it. Nothing else. This is the main difference happening. So if you're going to use the AH, if you're going to use the AS, what happened? The actual packet, right? There's this one. That's a inner header, and this one also present. And do we have any integration? Do we have any like encapsulation encrypted over there? No, you can see your information. You can see your information out there in AH. If you are going to use the AH, you can see your information. That's why it's not a recommendation to use the AH. Yeah, someone? Yes. Again? Wow. 1 minute. It's good. No, it's good now. It will not happen. So in H, what happened? Can you see that everything, right? Everything you can see. This is the only field, right? In H, right? This is the only field. H ICB. That is going to perform the hashing over there. That maintains the data integrity. It should not be modified. If some person is trying to modify, what happened? If attacker is going to try to modify, this ICB also will be changed, right? ICB stand for क्या था full form इसका यार? Integrity check value something. Yeah, I think so. This one is it. Influence thing. Yeah, integrity check value. Let me check it. Not even some ICB. Okay, integrity check value. H. Yep, integrity check value. And the rest of the same thing will happen. The SPI or a sequence number over there. The SPI is a logical connection, right? It's a maintain the logical connection between the two sides over there, and rest of the same thing, the sequence over there. That's going to maintain like your packets should not be like a replay attack will happen in your network. But this portion is very important in your H. And because of this, because of this reason, right? Because of this reason, can you see that? Because of this reason, we are not going to use the H. There is no confidentiality. There is no confidentiality. As compared to ESP, in AH, there is no confidentiality. We have an integrity, but there is no confidentiality. So always, even in your Cisco exam, what happened? Even in your Cisco exam, they will ask you to configure ESP over there. And even in the troubleshooting part, even the something is pre-configured, the pre-configuration, always you will see the ESP over there, not the AH. Yeah, my voice is still breaking. Seriously, what happened? 1 minute. 1 minute. 1 minute. I'm fine now. Okay, why still not? It's see, it's present. It's a previous was there, right? They introduced the AH in the different RSP. They have a ESP and AH have the different ISP. Sorry, RFC, right? So this is introduced by the different engineers. But nowadays we are not going to use this thing. H is there, but nowadays we are not going to use. It's like a RIP protocol is there, right? But who is using the RIP right now in these days? No one. Problem is problem, right? Thing is that, let me come back to the point. So ESP is giving in the integrity to app, of course. So crypto as a cam IPSEC asset. One minute. Most important command. So crypto as a cam detail, SA detail. By using this command, you can check whatever the configuration data you did, right? Encryption, hashing, authentication, DH, and laptop. This part, capability in the sense of what? Capability, is there any extra things that you are using in the IPsec? Is there any extra things that you are using in the IPsec that will seen as a capabilities over there? Will seen as a capabilities over there. Maybe like a dead peer detection, if you're going to use the dead peer detection, right? I think so. My internet connection is bad today. I don't know, everyone's thing. Internet is speed. It's good, right? I don't know why. That's good. So if you're going to use the dead peer detection and something extra feature in the IPsec, then you will see the capabilities option over there. But this is the most important command to troubleshoot your IPsec. You can check whatever the configuration that you did on a router, and you can check whatever the pre-configuration is present on your router. At the same time, so crypto IPsec SA is just going to tell you how many packets that have encapsulate, digest, and encrypted over there. So let me do one thing. Let's come back to the point. I'm just going to use the ESP over there, not the AH. That's not recommendation even, right? Do certain section crypto. So if you want to do modification, right? If you want to do any modification in the crypto, how do you do that? You just need to first remove the crypto on a particular interface, right? And then what happened? You just need to, if you're going to remove this person directly, can you see that? If I'm just going to remove this person directly, they'll prompt the error message. Already used, right? First remove the transport set, right, from the profile, the crypto map that you did, either your crypto map or the either the profile, right? Both are the same thing. So same thing is not there. We can say that this is the crypto map is the legacy now that we are using right now, and this is the advanced version of the crypto map. That's the profile over there, IPsec profile, that we'll discuss in the in the DMVPN. If you are going to implement the IPsec over the DMVPN on GRE, then you're going to use the profile over there. I'll show you this thing as well as, but both are the same thing almost, right? Nothing is different. This is the legacy now and this is the profile. Why we are not going to use the crypto map, I'll let you know as well as, don't worry. There's a difference is happening, a minor difference is there. So first we have to do, if you're going to directly remove the transform set over there, what happened? They will prompt the error message. So what we have to do, first I need to remove the crypto, oh sorry, transform set from the crypto map, and then I need to do the modification. Done. And now I'm going to remove this guy again. Perfect. Crypto IPsec transform set, T set, right? ESP 3 dash, or if you know use the integrity as well as, so I can use the ESP MD5 HMAC. If you want, you can use it. Otherwise, you can only use this person as well as, if you want, you can use it. Now, as I can set transform set, T set. Same thing I need to do on this guy, interface. I need to apply this person, crypto map, C map. Same thing on R3. I'll do one thing better to start the show history, and I'll copy this guy. I just need to change this behavior, right? Because on R3 it's not a crypto, it's a C map, it's a ABC. The name, it's a C map, it's a ABC. The name of the crypto map is ABC, and ABC, ABC, and ABC, right? All done, right? No crypto. Perfect. Copy. R3, all done. ISACAM is on now, and if you see the so do so transaction crypto, all good. Now let's do one thing. Let's come back to the R1. Clear crypto session, ping source 101. Done. Crypto will go up. So crypto, as I can say, the phase 1 tunnel, the phase 1 is working fine now, right? Repeat 1000. All my packet will be encapsulated with the ESP. Every single packet will encapsulate with the ESP. Every single packet. So how many packets I have sent right now? If you see, I've sent the 1000 packet, right? All this 1000 packet will be encrypted, right? They will have a verification will happen for this person, right? Integrity verification. Something has no packets. So crypto IPsec ASIC. What they are saying is the interface is running with a crypto map C map, right? My local address is what 12.1. That is my own interface IP address, right? This guy 12.1, right? This is the interface that I have enabled with the crypto map. This one. Local identifier means what? The address that you have defined, or we can say the policy that you have defined. If any packet that is coming from this person, and it has to be a host address, only this IP, not the complete network, and that has a protocol number, what? Then do one thing. If the remote identifier is also going to match with this person, make a VPN. Or perform the encapsulation, decapsulation, encryption, decryption, whatever you want. Every single thing will match it. For example, you have a same IP, right? So same source IP, same destination IP, but your protocol number is different. For example, 8 and 8. Nothing will work over there. Every single thing you have to match. Every single thing. Address, subnet mask information, protocol number, and port number. I simply not going to use the port number, right? It has its own protocol number. The current pair is what? 23.3. So R1 is saying that I have a current pair with the 23.3, and the port number that I'm going to use the 500, right? IPsec AM. How many packets I have encapsulated? 1004. 4 packet I already sent, right? The first time. And then next 1000 packet. Total. So this packet has encapsulate, encrypt, or digest. And when the reply is coming, so I have sent the 1004 packet to this guy. When the reply is coming to me, I need to perform the decapsulation. I need to perform the decryption over there. I need to verify the digest value. After that, what happened? Next thing. Which transform set I am going to use over there to encapsulate the packet? ESP DES. ESP is the protocol that I am going to use. DES is the algorithm. ESP is the protocol. And MD5 HMAX is the algorithm for the integrity. This is my SPI value. That has to be unique between these two sides. So this is my phase 2, right? This is my phase 2 tunnel. I'll do one thing. I'll show you this thing. Sorry, SPI should be unique. It's a unidirectional. So crypto IPsec ASIC. So if you see, this is my phase 1 tunnel, right? This is my phase 1 tunnel, and this phase 1 tunnel is valid for how many hours? By default, it's 24 hours. And what is the use of phase 1? To just exchange the key and authentication the parties, right? We can authenticate the parties over there. To authenticate my peer. And this phase 1 is valid for the 24 hours. Am I able to perform any kind of data over there? No data. This is just only for the key exchange and to authenticate my peer. What about the phase 2? The phase 1 tunnel is valid for the 24 hours. The phase 1 tunnel is valid for the 24 hours, whereas the phase 2 is valid for the 1 hour. So we can say the phase 1 for the 1 day validation, or we can say 24 hours. Phase 2 is just for the 1 hour. So can you see that one thing? This is the initiator SPI, right? So not initiator. So inbound SPI that I'm coming with this packet, right? And this is the outbound ESP. So every packet, right? Every packet, if you see whatever the packet we are exchanging over there, where is that? This one, ESP. Can you see that when the 12.1 this is the outbound SPI, right? Yeah, this one. Can you see when 12.1 is sending the whatever the packet this 12.1 sending, because I'm present on R1 router, right? R1 ESP. All this packet to the 23.3 we have a this SPI set to the this person. Can you see that? Same SPI. This is the logical connection, right? SA means what? It's a logical connection. Security parameter index, it's a logical connection. Whereas if you just have a look for the inbound, that is returning traffic, right? For the return traffic, what happened? When 23.3 is sending to me, I'm going to match with this person. So this tunnel, right, this SPI value is unique per session. It's like you can see that port number. It has to be unique, right, to make a session. So this SPI will remain valid. This SPI is remain valid for how many hours? Just for the 1 hour. By default, this is the 1 hour by default. You can change if you want, you can change it. It's not a big deal. I'll show you that thing. And you know one thing right now, my this value, right? If you see, my SPI is there, right? I can send my traffic because my phase 1 and phase 2 tunnel is both are present. These two tunnels are present right now. This is the phase 1 and this is the phase 2. Both are present, right? This is valid for the 1 hour, sorry, 1 day, and this is valid for the 1 hour, right? Both are present. Now let's do one thing. If you see, whatever the traffic that I'm sending, all my traffic is secure. See that? $10.14, and of course the sequence number, because the first I send the 4 packets, then I send the 1000 packet, and then I send the 10 packets. So total is 14. Right? If I'm going to send the next 10 packet, what happened? 24, right? 24, right? Yeah. See? The same SPI I'm going to use, for the next one. But what happened? Take example right now. Yep. That's what I'm showing. What happened? Try to understand. If I'm going to remove the phase 1, Tell me what will happen. Tell me what will happen if I'm going to remove the phase one. Will I able to communicate? So right now it is so crypto as a cam SA, not SA. Yep, SA. I have a. My state is active, right? The phase one is active. Clear crypto as a cam. What? Clear crypto as a cam. That's it. So crypto as a cam asset. Do we have a phase one? I just have a phase two. See, so crypto IPsec asset. Phase two is present for how many seconds now? 3000 seconds, right? Move. Can I send my traffic? See, all my traffic is successful sending. Traffic is moving. See? See now? This is not this is the mark packet, right? I'll do one thing. I'll send the 2 packets now. Fine. My phase one is not there, right? What I'm trying to show you, my phase one is not there. The meaning of that, this phase one tunnel, this is a phase one tunnel, right? And this is the phase two tunnel. The phase one tunnel is for the key exchange and authentication period. The phase two tunnel, data exchange. So what happened in this case? The phase one tunnel is totally independent. It's independent tunnel. Phase one, phase two. Phase one is totally independent. So if the phase one, the main mode, right, 6 packet, the first 2 packet, security association, 3rd and 4th, key exchange, and 5th and 6th, identification. This packet will be encrypted. Phase second phase, quick mode. Phase 2, 3 packet. How many fields are there? SPI, then sequence number, then SPI is unique per session, and sequence number is just going to make a reliability. No replay attack will happen. That is the use of sequence number. So for the one side flow, for this case, take example, if R1 is sending this ICMP request packet, ICMP reply, what happened? They have the same sequence number, right? Sequence 1 and sequence 1. Sorry. Then it will send the next packet. What happened in this case? For example, if I am sending the next packet, 2 and 2. Next packet, 3 and 3. So whatever the packets I'm sending to you, just give me the acknowledge of that packet, right? Like acknowledge number, that's it, nothing else. Done. So if this phase 1 is not available, take any chance, if the phase 1 is not more, right, not available, what happened? I can still send my data, right? I can still send my data. Nothing. This is because this is valid, right? Still, because this is still valid for how many hours? 1 hour. And this is valid for how many hours? 24 hours. If the phase 1 is not there, I can do the data exchange, right? Because you already gave me the P, right? You already gave me the key over there. But what happened, take example. If this key, this SPI is valid, right? This SPI is still valid, right? This is two things are there, guys. Don't confuse with this thing. Two things are present, right? One is this one. It's a kilobits, and this is the second over there. By default, it will take a second format. By default, it will take a second format. You can change. This is the thing will happen. You can change this thing as well as if you want. But if you see right now, my still show crypto. I'll do one thing. Show crypto as a cam. SE. There's no phase 2 is there, right? So crypto IPsec asset. Phase 2 is present. What happened? Let's do one thing. As the clear crypto session, right? Done. Yeah. Hey, hi. How are you? Hey, yeah. याद आ गया. कैसा है? बोल. हाँ. एक काम करो, मेरे व्हाट्सएप पे ना मुझे हाई लिखो, ठीक है? मैं तुमको शेयर कर दूँ. पेन ड्राइव में नहीं हो पाएगा, ज़्यादा है. उसके बाद ये है कि मतलब तुम मतलब मेरे पे लैपटॉप में नहीं है, उसमें सारे ड्राइव है, उसमें सारे ड्राइव पे अपलोडेड है. अरे स्विचिंग है, राउटिंग है, DHCP है, रिप है, OSPF है, VGP, सब कुछ है उसमें ड्राइव में. हाँ, तो इसलिए मैं बोल रहा हूँ, तुम एक बार मुझे हाई लिख दो, मैं तुमको शेयर करता हूँ सारा कुछ, ठीक है? 950 हाँ 1035 हाँ, ये नंबर ऑफ होगा, मतलब तुम मैसेज कर दो, व्हाट्सएप कॉल लग जाएगा, उस पर नंबर ऑफ कर रखा 950. ये देखो, यहाँ देखो. ऐसे कर दो, मैं तुमको भेजता हूँ 2-3 मिनट में, ठीक है? चलो, बाकी सब बढ़िया, और एवरीथिंग इज गुड. साथ में तो देखिए सब वीडियो में नोट्स में जगह है, जो सी का सब भूल गया, ऊपर से गंदा है कि फाइल चेंज हो गई. आई प्रोजेक्ट को पीछे पड़ के मैंने ऊपर चेक पॉइंट का भी दिया था एडमिन एक्सेस, और एफआई का भी दे रहा था एडमिन एक्सेस. ओके, मैं तो चलिए तो इसका सब पूरी तरह से कोई नहीं सकता. हाँ, जा रहा है, मैं तुमको मैसेज करता हूँ, उसमें बताता हूँ, सारा कुछ डिटेल देता हूँ, ठीक है? मैसेज करूँगा. So I did the clear crypto session, right? So if you see right now, what is the SPI's previous SPIs there? So this is our previous SPI, right? So let's do one thing. Let's copy this guy, and this is the previous SPI. Okay. And now have a look. So crypto session. Sorry. So crypto IPsec. Sorry. What is the command? ISACAM SA. There is no phase 1. So crypto IPsec SA. There is no phase 2. Nothing is there. Can you see any SPI? No. Nothing is. No packet is encapsulated. Nothing is decapsulated. Everything I have cleared. I have cleared the counter over there. The clear crypto session. This command is going to clear all the session over there. You can manually also remove the phase 1 and phase 2, but by putting this command, what happened, the phase 1 and phase 2 both will be removed. So both will be removed. And session, right? This session is going to include the crypto session. Crypto means what? The phase 1 and phase 2 as well as. If you're going to manually remove the phase 1, you can also do like this. The command is clear crypto ISACAM and hit enter over there. And for the clear phase 2, clear crypto IPsec SA, not SA, I think the IPsec. What is the command? Clear crypto ISACAM SA for phase 2 IPsec, not this one. Command ISACAM clear crypto SA. This was the second command. This one. So right now nothing I have, right? If you go back to the If you go back to the router number 3, so crypto ISACAM SA, nothing. So crypto IPsec SA. This will be changed. Alright. So now let's do one thing. Let's go to R1 again, and I'm going to initiate the connection, right? What I'm going to do, I'm just going to ping over there, ping, because this is the policy based VPN, right? So always you need to initiate the traffic. See, initiation has done, and now so crypto ISACAM SA. Phase 1 is coming up, and this is valid for the how many hours? 24 hours, right? And phase 2 is valid for how many hours? 3600 seconds, right? We can see the 1 hour. So now if you see, the SPI will be changed again. New session. For the new session, I need to have a new SPI. For the new session, I need to have a new SPI. Clear? Next thing. Do you know what happened? One minute, I need to see one thing. Yeah, it's changing now. Previously it was not changed. It's not changed. So previously it was 652. So new session will be made, right? So it will change over there. Now have a look. I see the interface 0/0, no crypto map CMAP. Done. Remove it. What happened? ISACAM is off. So crypto IPsec SA. What happened? Nothing. Sorry. Yeah. Then see guys, try to understand this to this part. पूछो.
Like we clear like phase 1 and phase 2 still like running, right?
Yeah.
Then after that 1 hour finish.
After the 1 hour finish, yeah, that's something to mind. 1 minute. That's I also have a question. Don't worry. Let me clear this part, and then I was coming to that part as well. Site to site VPN deploying. Right? One thing that's very important. I told you that we have two types of authentication, right? We can authenticate my peer in the 2 ways, right? we can authenticate my peer in the two ways. Right now, peer means what? This is the client side. This client, I can authenticate this peer with the two ways, right? Either you can use the authentication pre-share, or either you can use the CA server. Yeah, but read this one. In a basic or a small VPN deployment, pre-share key are commonly deployed because of the requirement of for the simplicity, ease of management, and the cost. Overruling the decision to implement an internal PKI solution or purchase the digital certificate from the external provider, it will require the cost over there. So for the easy management, right, easy simplicity or easy management and cost saving, we are going to use the pre-share key. But if you have a very large environment, right, if you have for example, if you have 100 plus sites, 200 plus sites, in that case you can use the digital certificate, or we can say the PKI solution. I will discuss this part once I'm coming to the SD-WAN part, right? In SD-WAN I'm going to discuss this part, how this PKI is going to work. Okay, don't worry. Okay, but once for the large organization, we always going to use the CA server based authentication. So this the ASA part is there. Okay, another thing is that, can you see that this is the ASA is giving over there? So depend on the module, right? Depend on the module, they will support the how many they can support the SA over there, security association, right? How many SA you can support, depend on the. So if you go for the different vendor, right? Sorry, not different platform model, we have different assets, how many SA they can support at the one time. So it's not like that every router is going to support the every like a huge amount of SA. It's totally depend on the model number. To the phase one, right? In the phase one, how many things I'm going to apply? In the phase one, I'm going to apply the peer authentication scheme, authentication, encryption, lap time, defilement group, and phase two, encryption, SA, lap time modes, and encapsulation protocol. Mode I'm going to discuss. There are two modes over there. One we have a transport mode, and one we have a tunnel mode. By default, it goes for the tunnel. If you see, by default, the mode will be tunnel. This is the default mode. Okay, you can change the transport as well as I'll let you know this thing how the mode will be changed and whatever the requirement of the mode. I guess phase one is done. Development key authentication. See, no, try to understand. Both are independent tunnel. Both are independent. It's not dependent on each other. (23) I didn't remove the 23. See, this is my logical connection. Try it. One minute. I didn't down the 23.3. Try to understand. This is my physical connectivity, right? This is my physical connectivity. I didn't down the physical connectivity. I have a two logical connectivity over this guy. This is the phase one and phase two. This is the logical connectivity. I just down the logical connectivity of the phase one. I didn't down this one, the physical connectivity. Of course, if the physical connectivity down, no communication will happen. Swami, are you getting this point? I just cleared the crypto logical session, not the physical one. The physical connect, you need to require the physical connectivity, of course. If your physical connectivity is not there, no communication will happen, nothing, never. I just removed the logical connectivity. I just trying to show you both are independent tunnel. Now, what I'm showing you, this command I want to show you, right? This command. Then why you configure only phase 2? Then why you configure only phase 2? I didn't configure the phase 2 only. I have configured the phase 1. That's I'm coming to the point. That's give me some time. I'm coming to the point. Let me complete this word. Okay, then I'm coming to your point as well as okay. What is the meaning of this command? See, what this command is saying that if you just remove this guy no crypto map cmap on this particular interface, what happen? Your ISA cam will be off, right? All good. And after that, if you put the command show crypto IPsec assay, what this guy is saying that no assays found. The meaning is very simple. If you apply this command on this particular interface, what happened in the background? If you just apply this command on a particular interface, what happened in the background? ISA cam will be on. Only this thing? No. Show crypto IPsec assay. Automatically your database table, which database table? Assay database table will be created. Sad. This is not that sad, right? SAD is a security association database. And what this database is going to do? This is the table, right? This is the logical table. This name table is the SAD over there. And in this SAD, this is the SAD over there. And in this SAD, you are going to install the information of the assays, or we can say SPI. After putting this command, previously if you see the interface 0/0, now I get this information, right? But previously, once I remove this person, what happened? No access form. The SAD is a security association database that is going to maintain your security association. See, two databases are used for each interface. Interface means what? Where I apply the crypto map. To store the assays, security association, and the policy information by each peer. Policy means what? Is talking about the ECL that you have created, right? The SAD is security association database, and the SPA is a security policy database. SAD and SPA. These two databases will be automatically created. Security association database, security policy association. So security policy database. The name of change is there. These two database table hold the information, a different information, but used together to determine where a packet belongs to the VPN. That is called as the interesting traffic, right? So each peer maintains a SAD for direction of the traffic on each interface. The SAD holds information such as SPI, secret keys, IPsec profile, and for the assay, and even the IPsec mode as well. Either you're going to create the tunnel mode or transmode related to the peer address, lifetime, that is you can define in the second or kilobits, and the sequence counter. SPD hold the policy information, interested traffic, or the SPI information. That's it. So this two database table automatically created after applying this command on our interface. So now if you see ping source show crypto IPsec assay. This one. The state is my active, right? This command is clear. What is the use of this command? Crypto ISAC MSC, not crypto map CMAP.
Yeah.
Now the question is coming from the Devendra. He said, okay, why do we need a phase 1 over there? Why do we need a phase 1 if the phase 1 is not required? If I'm going to down this phase 1, the phase 1 is not required. See, things are very simple. What is the use of phase 1? Key exchange and authentication. Key exchange and authentication. So tell me, and this phase 1 is valid for the how many hours? 24 hours. This valid for the how many hours? 1 hour. What happened? What happened if the phase 1 is not available? If the phase 1 is not available and my phase 2 is still valid for the 1 hour, so what happened? This time is coming on. So maybe the take example 60 second, right? Or 50 second, 40 second. Still I can send my traffic. Right? Phase 1 is not available, right? The phase 1 is not available. 40 second, 30 second, 20 second, 10 second, 5 second, 4 second, 3 second, 2 second, 1 second, 4 second, 3 second, 2 second, 1 second. He's trying to initiate, right? Hey, can I initiate my VPN? So it will look up for the phase 1. Hey, can you authenticate the peer? So what happened? The phase 1 is not there. How can I authenticate my peer? How can I exchange the key? If I'm not going to authenticate and key exchange in the phase 1, because this phase 2 is relying on the phase 1, once my SA will be expired. The phase 2 is relying on the phase 1 only if my SA will be expired. Otherwise, I'm not going to rely. Okay, no issue. See, right now I have one logical connection between this PC to this PC, right?
Okay.
And this logical connection has some separate identifier. That's the SPI value. The 1 2 3 4 5 6 this is the SPI, and 1 2 3 4 5 6 this is the SPI. So now the time left is near around. 60 seconds, right? Yeah. So this phase 1 tunnel is not there right now. Okay, the phase 1 tunnel is not there. This time is a 1 hour. So this 1 hour is a 59 second. 59 minutes has over, right? The 59 minutes has over. Now it will move the 60 second, 50 second, 40, 30, 20, 10 second, 9, 8, 5, 4, 3, 2. Still my data communication is happening, right? Because I have a SPI value. I have a SPI value, right? I can still send my data, right? Once it's coming to 1, 0, what happened? This SPI automatically will be invalid. Yep. So now, who is going to authenticate? Who is going to generate the key again? Phase 1. So do we have a phase 1 now? Do we have a phase 1 for the authentication? No. So if the phase 1 is not available after expiring the SA of phase 2, once the phase 2 SA will be expired, and if the phase 1 is not available, I cannot initiate the traffic to this person, So in this case, the phase 2 is relying on the phase 1, but both are independent to each other. Independent in the case of one. For example, I'm going to use the encryption in the phase 1 as a DAS. I can use the encryption in the phase 2 as a AES. Okay, the phase 2, phase 1 is valid for the 24 hours. The phase 2 is valid for the 1 hour only. So if you just have a look right now, well, I'll do one thing. See, I'll say that 1 minute. Crypto, it's a command called IPSEC Security Association. Lifetime. I can make it in seconds. I can make it 200 seconds. Man, fine. That's fine, right? That's fine, right? R3. Crypto IPsec command was the security association. As a lifetime will be 1 second in the 120 second. And what I can do? Clear crypto session right now. Both the sides. Let me initiate, right? First I need to initiate ping, and I'll do one thing. Okay, no issue. Let me initiate the packet right now. So right now I don't have any tunnel. Right now I don't have nothing the phase 1. So crypto ISAC MSC. No phase 1, no phase 2. No phase 2 is also not there. Nothing SP, no SPI is there. Phase 2 is also not present, right? Not phase 1, not phase 2. Neither I have a phase 1, not a phase 2, right? I clear crypto session over there. Right? Ping. Now what is the timer I have set for the phase 2? For the phase 2 I set the timer what? 200 seconds, right? This is for the 1 day. Right? Now. Done. Debug. Crypto. IPsec. Now show crypto. ISAC MSA. Phase 1 is there. Show crypto. IPsec assay. Show crypto. IPsec assay. Right? Clear crypto. ISAC M. Phase 1 is not there. $60. Wait for some time. Before the 30 seconds, they will trying to negotiate, right? They will trying to initiate the SPI. What happened? Some debug is happening. 80 seconds more. He's trying to initiate the connection, right? But what happened? He failed because the phase 1 is not available. Expiring the 32 seconds. But according to the Cisco, right? According to the Cisco docs, I'll show you this thing in the docs as well. According to the Cisco, he's saying that almost 30 seconds. Right? So it's not accurate time, it's almost 30 seconds there. Sometimes giving the 30 seconds, sometimes giving 31, 32, near around. What happened now? Can you see that? So crypto IPsec कैसे? 1 minute जी. एक मिनट देना भाई. Is there any packet exiting right now? This should be not there. Yeah, 1 minute. एक मिनट. एक मिनट. ये टनल फॉर्म नहीं करेगा. If your traffic is not moving, it will never form the tunnel. Yes. Bachelor. This is almost 10 Mbps, right? If you go in the kilobits per second. It has to not from the table. 1 minute. How they have found different certificates? Yes, not removing. It's not removing. Can you see that? It's not removing. It should be removed actually. Yep, it's not. It takes some time actually. It's removing now. So can you see that now I don't have a phase 2? I'll show you this thing as well. According to the source code docs, it's saying that near around 30 seconds. Yeah, if you see this line, yeah, it's coming now. A new SE is negotiated before the lap time of the threshold of the existing SE is reached, right? So to ensure that new SE is ready for use when the old one expired, the new SE negotiated approximately 30 seconds before the second of lap time that you have configured. Or if you configure in the volume, the traffic of the volume, then it is near around 300 kilobits per second. If the traffic, this is the most important line, if the traffic has passed through the tunnel during the entire lap, sorry, if no traffic has passed through the tunnel during the entire lap of SA, a new SA is not negotiated when the lap time expired. This is the point that we proved right now. They may now clear this point. Instead, a new SA is negotiated only when IPsec see another packet that should be protected. Then I will create it. So right now, I don't have a phase 2. Is that now? I don't have any SPI over there. So the phase 2 is down right now. There is no phase 2. Now if I'm going to generate the packet again, right, what happened? If you see. What happened? You can see this debug as well as stop this guy. And can you see this one? Where's that? Can you see? Only 3 packet has exited. Why this thing has happened? Because if I say the ping, can you see that? It said the ping 3.3.3 or source 101. In that case, what happened? Phase 1 I already have, right? If you have already phase 1, so I'm only going to negotiate with the phase 2. And then after that, I'm going to encapsulate all the packet with the ESP. But if your timer will expire, right? If your this timer will be expire, right now also timing is happening. Secret IPsec. Once this timer will be expired, what happened? If your traffic is not moving through the tunnel, right? If your traffic is not moving through the tunnel, I am not going to initiate this SPI. I'm going to remove this data. Initiate this SPI. I'm going to remove this database table. I'm going to remove this SPI from the database table. So this timer, right, is just going to tell you for how many seconds, right? Where's the time? For how many seconds this tunnel phase 2 will be valid? Clear? Devinder, question is clear to you? What about the phase 1? If there is no interesting traffic after the 24-hour, if there is no interesting traffic after 24-hour, the phase 1 also will be delayed now. It's also will be not available. Because this is the policy based VPN, right? Policy means what? Interested traffic. And this VPN is also known as an on-demand VPN. Why I'm saying on-demand? Because whenever the demand comes in the picture, I need to create the VPN. So if the demand is there, I will have a VPN. If the demand is not there, I will not have a VPN. See, expiring the 30 second. Previously it was showing the 32 second. Now it is saying the 30 second. So Cisco, according to Cisco, is saying the approximately 30 seconds. So it will be near around 30, 31, 32. But this thing is not possible in the route based VPN. In route based VPN, what happened? If you're going to implement the IPsec over the route based VPN, in route based VPN, what happened? Your SA will be still exist because your EHRP packet or whatever the protocol you are going to use, your EHRP OSP packet is still advertised through the tunnel, and on that tunnel the IPsec is enabled. So your SA will be still remain valid automatically. But in the policy based, it's on demand, right? If your timer will be expired, you need to again reinitiate the traffic. If you're not going to reinitiate the traffic, your phase and phase 2 will be deleted according to your timer. In the phase 1 also you can change the timer. For example, crypto ISA cam, because the lifetime is there. For the command, not policy, time, lifetime, I think so, yeah. So you can define the timer from this range to this range. So let's take example. I'm going to define this timer over a 300 second, right? This guy as well as I'll do one thing. Crypto as a cam policy 10. Lifetime will be what? I said that 300 second. And now I said the clear crypto session, right? On R3 as well as clear crypto session. Done. So let's initiate the traffic now. From R1. So I don't have a phase 1 and phase 2 right now. So crypto as a cam SA. The phase 1 is related, and phase 2 as well as IPsec SA. Phase 2 is also not there, right? Nothing is, no SPI. So let's do one thing. Let's change this. Let's generate the traffic, because it's an on-demand VPN. That's the meaning of on-demand. Means I need a VPN right now. So let's generate the traffic. I need a VPN. Let's generate the traffic. So now, so crypto. So updated peer 23.3 Urban SPI is like this one, right? So crypto Isaac MSC detail. So how many seconds this is valid for? Only for the 4 minutes, right? And my phase 2. $79 seconds. Just wait for some time more. As a debug crypto Isaac as well. SA is reaching to the threshold, right? 32 seconds. Proxy matching over there. Receive the SA, delete, notify, proxy match. So this is a 200 second timer. I'm going to send in the packets as well as, right? SA left duration 200 seconds, right? Processing the responder lifetime. IG phase 1 complete, right? So is as over. Okay. 2 minutes 50 seconds more. Phase 2 is still there by 54 seconds. Meanwhile, do one thing. Let's read the book. Okay, I need to discuss the PFS as well as, right? Okay, we'll discuss later on, not now. Okay, something else I can show you. Now this one. Let me remove this guy. Not this one, not this one. The same commands are there, right? Nothing else. Okay, they have configured. What is this? Actually, ASDM. They have configured through the GUI. Wait. Okay, this book is not so good, right? I can show you something else over there. If you change your this command I already show you, right? If you change the kilobytes, you can also change it. The phase 2 has removed, right? The phase 1, how much time is required? 1.9 seconds, right? Wait for some time and I'll show you something else. One more good thing was there. IPsec data plane, not this one. NAT travel, sir, we are going to discuss later on, not now. This one. Okay, yeah, I'll just show you the one thing that I asked you the question yesterday, right? The message ID concept, right? Why the message ID given in the phase 2, in the phase 1? That also you want. Just want the cookies. Why, my Gunther. Yep. See them in there. The message ID, the unique message identifier used to identify the protocol state during the phase 2 negotiation. This value is randomly generated by the initiator of the phase 2 negotiation. In this event, the simultaneous assay establishment, the value of this field will be likely to be different because they are independently generated, and thus two security assessment will be progress toward the establishment. Okay, during the phase negotiation, why it's not given the 0 over there. During the phase 1, its negotiation will be must be 0. Why is it's given the 0? I'll show you that thing. Where's the rate I did it? Alright. In your RFC, this thing is given, right? Why this thing is given in the phase 1? Some regions was there. I'm not able to remember that reason. What's the reason is behind it? I'll do one thing, I'll find it in message ID over there. Message ID, as you can see, message this PI is associated with the negotiation. Next one, information exchange. This is the generation of message ID information exchange. This should be independent on again. This will, okay, this will, yeah, this one, this line. And this will also makes your dat, right? This will also makes your dat your phase 1 has completed negotiated successfully, right? Once the phase 2 is coming, right, in the phase 2 what happened, the phase 2 will identify, okay, the phase 1 has completed successfully based on the message ID concept. How do I know that? It's something like that, you know, the data link layers has information of the network layer, and network layer has information of the transport layer, and transport layer has information of the above layer. Same like this concept is happening in the message ID. The message ID putting in the quick main mode to just inform that the quick mode, hey, I'm done with this phase 1, now you can negotiate with the phase 2 as well. As this field must be there in the phase 1, and that's why it's disabled over there. Why this thing is disabled? To just confirm the phase 2, hey, I'm done with the phase 1, now you can negotiate with the phase 2. That's it. So now can you see no connection is there? Why? Because for which peer? So if you know communication will happen, I don't have the communication, I just change the phase 1 timer is the what, I just manipulate the phase 1 timer is what, the phase 1 timer is I manipulate over there of 400 second, and the phase 2 I just did over the 200 second, right? What happened if no communication is happening? Right now both are working fine, right? Phase 1 and phase 2 is there, but if no communication happen, if no communication will happen, next 5 minutes 6-7 minutes, what happened? Next 7 minutes, what I'm just going to remove this phase 1 phase 2. This is the logical, right? This is the on demand. But again, if I'm going to create, right, let's take example, you all ping and source 101. If I'm going to create again, what happened? The on demand process to crypto IPsec MSC, the phase 2 is, phase 1 is there and phase 2 is also there. It's done. They're in the clear now. Almost. Anyone else has any questions, guys? Done. Done now. हो गया